As you can see, all of the geometric shape of our design turns into green, which means that we have successfully processed all the geometric designs of our geometric shapes of our design. Okay. In this case, if you're going to zoom out or zoom in the parts, there is some corners that was not reached by the processing. Okay. What we're going to do, we're going to treat the corners so that this portion of laser processing would reach into the, or would penetrate more. As you can see, it's far, the distance of the machining to the side is 2.89 millimeter. What we're going to do, we're going to do corner treatment on parts. We're going to click rounding and then click OK, then click the contour. Now it reaches, or it penetrates more deeper on the corner of the geometric design. Earlier our measurement is 2.68. Now we have approximately 1.07. Okay, as you can see, the red portion symbolizes the piercing of the laser machine during the processing. If it turns into red, it means that there is a high pressure applied by the machine to our part, which might result in different kind of defects. So what we're going to do, we're going to softly pierce the parts. I'm going to change it. I'll go to modify piercing, apply on all parts, all contour and parts, and then click OK. Then click the contour. Now all the piercing turns to pink, which means we are applying a soft piercing. Okay, so we're going to check if all the processing has been made. So we're going to run a simulation of the laser processing. I'm going to reduce to half, then click play. As you can see, that is the sequence cutting of the laser. It's being shown simultaneously in its simulation. So it seems that we don't have any problems in the cutting because all the geometric shapes of our design have been processed, and we have applied a corner treatment also on the corners that was not reached by the processing. However, we already adjusted, so it penetrates more than the normal cutting. Okay, so that's it. So I'm now going to generate an NC file. The NC file video trial. I'm going to save it in the laser machine path, which is we place in the drive Z. Okay, I'm going to cool ornamental folder. Okay, cool 107. Then click OK. From the parameters, I'm going to check so that it should automatically save TMT, which is the sheet with technology, the sequencing. In this case, if the parts have a sheet, we are going to vaporize the sheet first before cutting. Okay, in the sheet position, where we have to automatically measure the sheet by putting with height regulation. If the cutting process have a cut eye detection, so we're going to click cut eye. So in this case, we don't have cut eye, it's only a regular cutting. I'm going to tick with height regulation. The setup plan. The setup plan will be generated into PDF file. And then I'll click OK. Okay. Now I will go to the folder of the laser machine, which is on the drive Z. I'm going to open the setup plan that will be the reference of the operator and his processing. Cool 107. Okay, here is the PDF file, which is the setup plan. So that's it. So we have now a setup plan that will be used by the operator in his laser cutting processes. Okay, the total machining time will be shown also. In this case, it will be processed within 43 minutes and 40 seconds, this particular design. Okay, so that ends the programming for the TrueTops or TrueLaser 5030. So in our case, we're also cutting rectangular tubes, square tubes, and round tubes. We're able to cut all of those parts, so I'm confident that I can do also the same programming in different TrueTops or Trump machines. Okay. Aside from the sheets, the mild steel, the stainless steel, aluminum steel, I was able also to make programs for acrylic plastics, for woods, okay, and brass sheets. So hopefully I can do the same again. I'm just going to adjust the NC blocks, and then we can now run the program using that will be used for different kind of sheets. So thank you. That's all.